Welcome all. Our today's topic is estimation methods. What is estimation methods? As we have discussed in the previous videos, in our previous lectures, that estimation is very important for a good project preparation and for a successful project as well. So we have some well defined methods to estimate our cost, size, and all other aspects of related to the project. So let's start the topic. Estimation of various project parameters is a basic project planning activity. As we have discussed, our main important project parameters are project size, efforts, project duration, and the cost of the project. These estimates not only help in quoting the project cost to the customer but are also useful in resource planning and scheduling. We can, if we have a good estimate, we have a better idea about our project, then we can manage the things well. Here we have three main broad categories of estimation techniques. These are empirical estimation techniques, heuristic estimation techniques, and the analytical estimation techniques. The most common techniques is empirical. Here we use some past data. Then the most common example of this is like COCOMO estimation model. We will learn about this in the upcoming lectures. So let's start with the first one, that is empirical estimation technique. Empirical estimation techniques are based on making an educated guess. As we have discussed here, an expert or an experienced person will guess about the project parameters, and this guess will be based on his or her experience or the related to the past data as well. Although empirical estimation techniques are based on common sense, different activities involved in estimation have been formalized over the years. If you can think or you can understand this type of technique, as you are an expert of a subject and you have worked for a particular topic by many years, then you have an idea to complete these kind of project. So this will help to estimate the our ongoing or upcoming projects. Here two popular empirical estimation techniques, that are expert judgment, and second one is Delphi cost estimation. Let's start with first one, expert judgment technique. In this approach, an expert makes an educated guess of the problem size after analyzing the problem thoroughly. As the name suggests, expert judgment in me means there will be a expert which will make who will make a guess about the cost, size, and duration of the project. Okay, This technique is subject to human errors and individual biasness, as the human involved in this technique show there are some possibilities of human errors, and also the possibilities of individual biasness about related to any topic, any parameter that could be happen. Our next method is Delphi cost estimation. In Delphi cost estimation approach tries to overcome some of the shortcomings of the expert judgmental approach. Like Delphi estimation is carried out by a team comprising of a group of experts and a coordinator. It means uh, at the place of a single expert, we will use a team in which there will be a coordinator who will coordinate all the team, and if there are a number of experts we have, so the human errors possibilities, individual biasness possibilities, this will be overcome. Estimators complete their individual estimates anonymously and submit to the coordinator. The coordinator prepares and distribute the summary of the responses of all the estimators and includes any unusual rationale noted by any of the estimator. Based on this summary, the estimator re-estimate. This process is iterated for several rounds. It means we will continue a chain or a series of estimations till when we will get a possible outcome. If any point all the team members and the coordinator will satisfy, then that this is the better one, this is the better choice, then this process will end. Okay, this is our next techniques, next major technique, that is heuristic technique. In this technique, assume that the relationships among the different project parameters can be modeled using suitable mathematical expressions. Once the basic like independent parameters are known, and the other dependent parameters can be easily determined by substituting the value of the basic parameters in the mathematical expressions. Heuristic technique is based on the mathematical basis, mathematical expressions. Like we will have some independent variables, we will have some dependent variables, and with the help of independent variables we will find the dependent variables as well. Here we will divide this heuristic estimation model in two classes. The first one is single value model, and second one is multivariable model. The single variable model is on your screen. As the name suggests, single variable, it means it would have a single independent variable. Here is an equation, that is estimated parameter equal to C1 into E D1, and the here E is the independent and C1 D1 are dependent. The basic COCO model is an example of single variable cost estimation model. Sorry, I have tell you about COCOMO in empirical model as well. This will also the example of heuristic as well. The second one, multivariable cost estimation. Here, as the name, here will be multi independent and variables. The equation as on your screen, estimated resources equal to C1 into E1 D1 plus C2 into D2 E2 D2. Here E1 E2 are basic independent and all others are dependent variables. Okay, so this was the heuristic estimation model, and these are the two types of that particular. Now we have another estimation model, that is analytical estimation technique. Analytical estimation techniques derives to required result starting with basic assumptions regarding to the project. Thus, unlike empirical and heuristic technique, analytical techniques do have scientific basis. As in empirical and heuristic, there was no any scientific basis. Here, there is a famous scientist named Halsted, Maurice Halsted. He have provide the scientific basis to estimate about the project and provide some scientific rules to estimate these parameters. So let's start with the Halsted software matrices, and these are called Halsted's software matrices. Halsted's software matrices are a set of measures proposed by Maurice Halsted to evaluate the complexity of a software program. These matrices are based on the number of distinct operators and operands. You all know what is operators and what are the operands, and this technique is based on these. Here we have some fields of Halsted matrices. Uh, these all are used in the upcoming equations, like program length is denoted by n, program level will denoted by L, time to implement for T, vocabulary size N, program difficulty D, program volume V, and the program effort represented by E. So let's start with the Halsted matrices. Halsted program length will be the total number of operands and total number of operators in any program. This will be n equal to n1 plus n2. The estimated program length is n cap equal to n1 log 2 n1 plus n2 log 2 n2. These are the well defined scientific formulas provided by the Maurice Halsted. The Halsted vocabulary n will be n equal to n1 plus n2. The program volume will be measured by V. This is denoted by V, and the value of V will be size into log 2 vocabulary, and we can denote it is like n equal into n into log 2 n, and the error will be volume upon 3000. If we have to find errors, we will find from this formula. The potential minimum volume V star will be 2 plus n2 star into log 2 2 plus n2 star. N2 star is the count of unique input and output parameters. Okay, now the program level L will be find by V star upon V. Another formula for this, L cap equal to 2 into N2 upon N1 N2. The program difficulty will be calculated by D equal to N1 upon 2 into N2 upon N2, or there is a different formula, D equal to 1 upon L. By this formula we can also, if we have program level, then we can find program difficulty easily. Next one is programming effort. Programming effort will be E equal to V upon L, and the another formula is D into V, that is difficulty into volume. By these formulas we can find these parameters as well. Programming time will be T equal to E upon F into S, shows time in minutes, and this will, the result will be produced in minutes. Here the concept of the processing rate of the human brain developed by psychologist John Stroud is also used, and the Stroud's number S is therefore Stroud's moments per second, with S will be greater and equal to 5 and the less and equal to 20. This will be the standard value of S. Holsted uses 18 in in his study. The Stroud's number S equal to 18 moments per second, and a seconds to minutes factor F equal to 60. So by this, by putting these values in this formula, we can get the programming time. Okay, so these was some programming techniques, uh, estimation techniques basically we have studied today. In the upcoming lecture we will learn about some estimation models. Whatever we have learned today, you will not see these in some books in your syllabus as well, but these techniques are the basis. Okay, which techniques you have studied and you will study like Kokomo model, then what is the base of these models? These models base are on your screen. These are the basic techniques which will be used to produce these refined models in front of you. Okay, prepare your good quality notes and be in learning mode always. This is all done in this lecture today.